Hey everybody, this is Alex Merced and welcome to this presentation from Data Lake to Data Lakehouse, the challenges, the evolution, the journey. And before we get started with this presentation, let me just tell you who I am. I am a developer advocate here at Dremio. I have worked as a developer in the web and data spaces in the past. Now currently developer advocate here at Dremio, spoken at events like Data Day Texas, OSACon, P99Conf, Data Council. I host several podcasts, which we'll talk about in a moment, and also I am the co-author of this upcoming book, Apache Iceberg, The Definitive Guide. Okay, if you want to get an early copy of that book, just scan that QR code right there so that you can get an early copy, see what we've written so far. More is constantly being added to that early release, hopefully to be slated for release early 2024. And I'm also the host of many podcasts. So there's my solo data podcast, Data Nation, Select Star from Data Lake, which is a podcast I do with my counterpart here at Dremio, Dipankar Mazumdar, and Gnarly Data Waves, which is a weekly broadcast from Dremio. We bring in people from all across the data lakehouse space to discuss many topics related to the data lakehouse space, as far as like looking at individual implementations and how they've saved people money and what choices they made and when they were vetting their data lakehouse vendors, talking about catalog level versioning, table formats, migrating from on-prem to cloud, all sorts of different great topics. So make sure you subscribe to all of these programs on Spotify and iTunes and to not miss really useful, practical information. But with that, let's get to talking about the big picture of what was and where we're going. Okay, so what was is the status quo. Okay, so essentially what would happen is you would have your data sources. Okay, you would ETL that data, meaning export, transform, and load that data into a data lake, which is just acting as a giant storage repository for your structured and unstructured data. So the idea is that, okay, I have a copy of all my data in this big place where I can reach to it whenever I need to. It's a lot more affordable than putting all my data in a data warehouse. Then you would just take sort of your high priority data, ETL that, make a copy of it into your data warehouse. And then from your data warehouse, you start creating data marts, which sometimes would necessitate even additional copies of that data. And then some of your analysts using these data marts to fuel BI dashboards and ad hoc analytics might decide to create their own mini copies of this data, okay, local to their machines to help you to make BI dashboards a little quicker, BI extracts, things like that. And so this would cause a couple different problems. You would have duplicative storage costs because you have so many copies of the data. So that costs money, but also you have like the whole governance issue where you don't know how many copies there are and making sure that all those copies are consistent and meeting all your regulatory needs because you want to make sure that any PII is kind of hidden among all these copies. You have duplicative ETL costs because you have to pay for the compute for moving that data from place to place and other associated costs like egress costs and things like that. And then you have this huge repository with all your data lake, which is very limited in usage. Okay, the tools operating directly in a data lake, oftentimes, they can do read-only ad hoc analytics, but, really wasn't the center of your data gravity. What if it could be though? That'd be pretty cool, right? But what would it take to make that happen? What would it take to take my data lake and use it more like a data warehouse? Well, under the hood of a data warehouse, you have a lot of different pieces, like how the data is stored, what the actual metadata on top of that data is that the actual query engine uses to create its query plans. And all of this is sort of abstracted away into proprietary logic for a little bit different for each data warehouse platform. Well, what if we already have a storage layer, right? We're already storing data as Parquet. So we already got that storage piece. And we got query engines that can already query my data lake. So really all that's missing is that metadata layer that's going to allow for that more efficient query planning, allow for asset transactions and things like that. And this is where data lakehouse table formats come into play. And particularly, I want to talk about Apache Iceberg. Okay, so basically what it takes to make this transformation is, one, that metadata. So that's what the Apache Iceberg performs, a standard open format for metadata that allows engines to be able to read that data in your data lakehouse in a way that enables asset transactions. Okay, but we can take that a step further. We introduce another open source project, which is Nessie, which is a data catalog that basically allows you to allows versioning of the data in your data lake. So Nessie as a catalog would track all your individual Iceberg tables, so that way any engine can discover which Iceberg tables exist in your data lake, but also be able to version it, which allows you to enhance this whole idea of let's make less copies. So if you wanted to create a copy of your entire catalog of tables that someone else can then play with, experiment with, all you have to do is create a branch which doesn't actually duplicate the physical data. So you're not duplicating your physical storage costs to create a copy for ad hoc experimentation and exploration of the data, because it's just a branch. Okay. Iceberg enables ACID transactions, so now you can be doing updates and deletes on your data lakehouse. But Nessie, that Nessie catalog, not only does it enable that sort of zero copy cloning possibility, but you also have now multi-table transactions, because you can create a branch, transact multiple tables, and publish them through one merge. Allows you to isolate that ETL work so that you can do more data quality and data validation. Allows you to be able to roll back your entire catalog in case there's a disaster. So for easy disaster recovery, it makes the data reproducible because you can tag different commits on your entire catalog, so that way you're able to replicate your entire catalog. You're going to have all these sort of benefits. And the cool thing about Nessie is that right now it mainly works with Apache Iceberg, but its architecture allows it the possibility of being able to work with tracking all sorts of different sort of data lakehouse bits and be able to track versions of them and whatnot, to become more and more sort of like the arbiter of truth for your data lake. And now, since your data lake house, your data space, you have this metadata layer that basically bridges that gap between the query engine and the data storage. You can now operate like a data warehouse, that's called a data lakehouse, because your data lake is now operating like a data warehouse, allowing tools like Dremio to have a much more robust set of things that it can do with the data on your data lake. Okay, and then Dremio is going to provide also the benefits. But just to kind of take a look at this architecture, from a bird's eye view, you got your data storage layer, which doesn't have to be object storage. It could be on-prem HDFS. The beauty of this particular setup is that it's storage agnostic and can work regardless of which cloud vendor you choose, or whether you choose to be on-prem and use something like HDFS, or on-prem and use an S3 compatible storage layer like a Minio. You have options. But the idea is that whatever storage layer you have, you choose the one that best fits your use case, and then you are going to store that data as Apache Parquet files, more than likely, because it's a binary columnar format optimized for analytics type workloads. And those files will have a metadata layer on top of them, which is Apache Iceberg, which is going to enable things like ACID transactions, table evolution, time travel, and having a consistent view of that data. And then we'll be able to track all those distinct Apache Iceberg tables using a catalog in Dremio Arctic. Dremio Arctic is a cloud managed data catalog that's powered by that open source Nessie project that I discussed earlier. So you get all those versioning benefits of Nessie, but you also get a intuitive UI to help manage that catalog, and automated table optimization, which we'll talk a little bit more later on. And then the other half of the Dremio platform is Dremio Sonar, which is the query engine, which is going to provide you very fast query processing on the data lake. An intuitive UI that's going to allow you to manage a semantic layer to organize, document your data. Allows you to federate your data sources. So if you have other data in a database or a data warehouse, that can be all brought in and unified on the Dremio platform, and makes it an easy center of access for your consumers, because wherever your data is, whether it's in your data lake or your data lake house, or in a database or in a data warehouse, your end users should be able to connect to Dremio in one of its many different interfaces, whether it's its UI, Aeroflight, ODBC, JDBC, the REST API. Regardless of how you connect to it, they can pull down that data. Ideal world, you use Apache Aeroflight, which is going to allow you to bring down that data at blazing speeds, because that's what it's built for, analytic data transport. And then you can pull it into your favorite tools of choice on your local machine, whether it's a Jupyter Notebook, Pandas or Polar's data frame, a DuckDB relation, or just to feed a BI dashboard in Tableau or Power BI, or really any other BI tool to make use of that data. Okay, so essentially, these are sort of like the pieces. And again, we'll give you another sort of summary at the end of this. Okay, but let's just zoom in on Apache Iceberg, because again, Apache Iceberg is that layer that really sort of fills in that gap between, again, the query engines, going from, hey, I can read your data and do some queries in your data lake, to now, hey, I'm going to be able to treat your data lake as like a full-on database, aka a data lakehouse. And Apache Iceberg's architecture really lends to this, because the way Apache Iceberg works is that you generally have the metadata layer. So again, that metadata layer is made up of three parts. There's the metadata file that basically says, hey, this is the table schema. This is how the table's partitioned. Here's the table's latest snapshot. And then basically using that, an engine can determine, hey, what snapshot they want to query, which is documented in a manifest list file from which they can scan all the different manifests of files that are in this particular snapshot and take a look at that manifest partition stats to be able to say, okay, I don't need this group of files. I don't need this group of files because they're not related to this query based on the query filters and predicates. I don't need these files. Then once it knows, hey, which manifests are relevant for this query, it can go into these manifest files, which are the actual listing of individual data files, and find stats on each data file and say, okay, I don't need this file, I don't need this file, I don't need this file. So this way, all the planning is done purely from the metadata. Okay, never does it have to do any kind of listing operations or other file system operations to understand what files it needs to, which is going to be a lot faster because those file listing operations can really be, they can add latency. So you end up getting a query plan that's going to scan the narrowest number of files, narrow files you need for that particular query for a much, much faster query. Okay, and it's all using this metadata tree. And even though every time you change the table, a new metadata file is created, the current metadata file, like what is the current source of truth for this table, is always tracked by the catalog. So every time the table changes, the catalog gets updated, which would be Nessie in this particular instance, would now know and be able, and basically that becomes the arbiter of truth. So basically an engine would always go to the catalog and say, hey, what is the current metadata? And then get pointed to the metadata file and then be able to reconstruct and plan the query from there. Okay, so that's essentially the architecture of Iceberg in a nutshell. I do have videos where I go over that much more in depth. So there's a video that I put called Iceberg Whiteboard Overview if you want to see me like just basically construct it step by step. Okay, but there are other table formats. Like you might have heard of like Delta Lake and Apache Hoodie, but there are reasons that are unique to Apache Iceberg on why you may want to choose the Apache Iceberg format, such as partition evolution, which is going to allow you to change the way the table is partitioned without having to rewrite the whole table. Okay, your needs may change over time, and what it does is say, hey, if I've been partitioning the data by year, going forward, I'd like to partition by month. Okay, without me having to rewrite all the previous year's data. Compatibility mode. This is just going to allow you to store your data on object storage in a more optimal way to avoid bottlenecks. Okay, because Apache Iceberg parts ways with the idea that how you read your data is detailed to how the table is organized in the file system. Meaning you don't have to have a folder for each partition. You can break up those files across multiple folders, which is important on object storage where there might be throttling on too many requests to files within a particular prefix, aka a folder. Okay, so basically you can get better performance on a object storage. Okay, and that goes beyond what Dremio gives you with its columnar cloud cache, which also practices a lot of really smart caching techniques to give you better performance on object storage and also even lower your access costs on object storage. So you put those two together, you'll get some not performance and cost magic. Hidden partitioning is basically a feature that basically makes it easier to take advantage of partitioning. So instead of saying, hey, this is the partition column, you could say, hey, this table is partitioned by X column, but you can also say the table is partitioned by a transformed value of a column. So that way, if you want to partition the data by year, you don't have to create a separate year column. You can say, hey, I want to partition based on the year transform on the timestamp column. So the timestamp column is the partition column. So any queries filtering on the timestamp column will get the benefits of partitioning, even though it's still tracking it's partitioning based on that transformed value. The end result is just that your end users don't have to worry about extra columns that they may need to query. They can just query what they would naturally query and get the benefits of partitioning, which means less people, and not everybody has to become an expert in how every table is engineered to benefit from how to query that table fast. Basically, Apache Iceberg is an open spec. Okay, it doesn't try to go beyond that as a project. The benefit of that is that it just goes say, hey, here's the spec, here are tools to help you implement the spec, and basically allows everybody else to kind of build on top of Apache Iceberg. And the beauty of that is because it takes that approach, that really open approach, it's been able to get a lot of adoption between different tools because it's easy to adopt, it's easy to understand, because it has a very narrow sort of, okay, here's what we provide you. We're providing you how the metadata should look like, and tools to help you read and write that metadata. That's sort of the scope of the project itself. And then engines build support beyond that, and like querying that. Okay, data as code. So it goes back to that open source project Nessie I mentioned. But the cool thing about Iceberg is that it has the ability to take advantage of versioning at different levels. Most formats can take advantage of file level versioning, which oftentimes marries you to a particular storage format. So you have to use object storage sometimes. But when you have table level versioning, which is built into Iceberg, so you can branch any Iceberg table individually, or if you have catalog level versioning using Nessie, those do not depend on sort of where the files are stored. So in that case, you can, if you are using something like a Hadoop or a non S3 compatible storage layer, you're able to still use that and still get the versioning and CI/CD benefits that come with that when using basically a Nessie-based catalog like a Dremio Arctic. Okay. Openness. The actual Apache Iceberg project is super open. Okay, all the meetings discussing sort of the evolution of the project are public. Anyone can join and see how these meetings go and what they're discussed and be part of the discussion. Generally, anytime there's a new feature for the core spec, it requires a proposal that gets vetted by the community. So generally, there's no surprises. You're not going to find out one day that a new feature got released and there was no discussion of it prior in a public forum. Okay, this gives you sort of the ability to understand what's coming and plan around what's coming instead of being blindsided by a project that might be steered by one party so much that they can surprise you. Okay. Wide variety of prominent contributors like Netflix, Apple, Dremio, and more. Active Slack channel, which can be used not just a customer support channel. Okay. Basically it goes beyond that. There's where discussions of the development of the format happen. So again, all aspects of the development of the format are transparent, whether it's on its mailing list, in these public meetings, or in the Slack channel, which are all publicly visible, publicly accessible, and allows anyone to participate in these conversations. And the beauty of that is, again, no surprises. Allows you to kind of get a feel for sort of where the project is going when it's getting there, so that way you can make decisions with certainty about how you're going to plan your future data infrastructure. But what if you want to migrate? So now, hey, this all sounds great, Alex, but how do I start getting my data over to Apache Iceberg? There's sort of two approaches. You can do an in-place migration, where basically you take the existing data files you have and write Iceberg metadata to them. Or you can do a shadow migration where you rewrite the data files and create the Iceberg metadata on top of it. Both of these are not hard at all to do. As far as how they are done, you can take this QR code, which will take you to a blog post where I discuss exactly sort of the mechanism for that on the Dremio blog. And again, you can find the Dremio blog at dremio.com/blog. Okay, where me and the Dremio team have written several articles on all sorts of different topics regarding Apache Iceberg. Okay, when it comes to maintaining Apache Iceberg tables, there's generally going to be a couple things you want to do. You want to do compaction because you want to make sure that you don't have too many small files, and you want to group them into bigger files for better performance. Okay, you're going to want to expire snapshots, so that way you're not retaining data files for old snapshots you never plan on querying. You can do this manually. You can do this, using Iceberg's APIs, which require you to use Java or Scala scripts. You could use Spark and use the call procedures in Spark, but then you have to use Spark to do that, which you may or may not want to do. But a nice thing is the Dremio platform gives you an easy way to do this using its optimize and vacuum commands. Okay, giving you sort of an even easier intuitive SQL path to maintaining your Apache Iceberg tables. Whether it's the optimize command, which allows you to say, hey, you know what? I want to make this table more crisp. Take any files that are too small, below a particular minimum size, and then mix them together and try to keep them within a target size no bigger than a maximum. Okay, because again, fewer larger files are going to get you better performance than many smaller files. Okay, and so it becomes simple as just running this SQL statement, and then your files are now compacted. Or, basically say, hey, I want to expire any data older than this point. It will then expire all those old snapshots, clean up any data files that are only associated with those snapshots. So again, a file like this one right here, which is also associated with a valid snapshot, will not be cleaned up, so it won't break your valid snapshots. So it makes it pretty easy to do this manually. But you know what's even better? Doing it in an automated way. So if you're using specifically that Nessie powered Dremio Arctic catalog, that is basically a cloud managed Nessie catalog that Dremio provides, you can actually automate those tables and you can set a schedule. Okay, you can sit there and right from the UI and say, hey, on this schedule, optimize that table based on these parameters, and then it will run that job on that schedule for you, so you don't have to think about it. You can just enjoy nice, crisp, well-performing Iceberg tables. Same thing when it comes to cleanup. Okay, you can say, hey, ever so often run a cleanup job, expire all tables that are older than this amount, and we'll then run that operation, expire those older tables, delete any of those data files that would then be valid for cleanup, so that way your storage is nice and clean without you having to kind of keep an eye on it all the time. So basically making it much easier to maintain those Iceberg tables in your data lakehouse. When it's all said and done, this is pretty much what this infrastructure would look like, this story would look like. You would just have one ETL pipeline, basically your data sources into your Iceberg data, okay, and on your data lake. Now, and then those tables will just be automatically optimized on a schedule based on that Dremio Arctic catalog, okay, which is automatically integrates to the Dremio platform. So basically having it work with the Dremio Sonar query engine becomes really easy, okay. From that Dremio platform, you can then create documentation on that data, organize that data into folders, accelerate queries using a feature called data reflections, and basically that data becomes really easily deliverable to those who need it, because you have this open access layer where people can access it via the UI, so that way they can self-service curate their data sets. So you can just pretty much give them access to the raw or almost raw data sets, and basically they can go from there and actually curate the views that they need. You don't necessarily need to have everything done through several different data engineering requests, which allows for a much faster delivery of these data sets to the end user, because Dremio's UI is just so intuitive. Long as you have the right documentation, people can understand the data they have access to and create and derive the data they need. Okay, so self-service data preparation. Okay, using Aeroflight, the REST API, JDBC, ODBC, they can be pulling this data into analytics applications that they're building, notebooks with ad hoc analytics, and BI dashboards. And there's actually, right into the UI, there's built-in integration with Power BI and Tableau, but basically there are integrations into pretty much any BI tool you can think of. So basically using Dremio with your favorite BI tool becomes pretty easy. And then when you add in data reflections, particularly aggregate data reflections, which basically creates a physical representation of the aggregate stats of a particular data set, allows you to kind of have sub-second dashboards, BI dashboards, directly from the data on your data lake. So without having to create any BI extracts, without having to create all these data marts, you just basically operate directly from your data lake. So basically it gives access to all your data consumers for the data they need without them having to really know all the stuff behind, but everything behind is now really simple. It's just land the data in Iceberg, and then Dremio handles the rest. Okay, and then you have a data lake that operates like a data warehouse, aka data lakehouse. So hopefully you guys enjoyed this. Again, make sure to follow me on Twitter so you can learn more at AM Data Lakehouse. I do this presentation and many others regularly, so make sure you follow me on LinkedIn and here on Twitter, so that way you can hear about when I'll be doing talks like this, at a meetup or anywhere. Okay, make sure to subscribe to these podcasts on Spotify and iTunes, such as Data Nation, Select Star from Data Lake, and Gnarly Data Waves. But with that, I'll see you all around. Have a great day and enjoy.